Hello everyone. Today we'll be looking at question number 45 from Chemical Engineering GATE 2016. At 30 degrees Celsius, the amount of acetone adsorbed at partial pressures of 10 and 100 mmHg are zero point 0.1 and 0.4 kg of acetone per kilogram of activated carbon respectively. Assume Langmuir isotherm describes the adsorption of acetone on activated carbon. What is the amount of acetone adsorbed in kilogram per kilogram of activated carbon at a partial pressure of 50 mmHg and 30 degrees Celsius? There are four different options given to us. Option A 0.23, option B 0.25, option C 0.30, option D 0.35. This is a question from adsorption part of mass transfer operations, and the reference NPTEL lecture series for the concept of adsorption can be available in lecture 1, week 10, adsorption, types, nature and isotherm mass transfer operations by Professor Chandan Das, Department of Chemical Engineering, IIT Guwahati. So here it is given that the adsorption follows Langmuir adsorption. So the general form of Langmuir adsorption is given as C is equal to AP by 1 plus BP. Here C is the concentration of acetone being adsorbed, which is given in kilogram of acetone per kilogram of activated carbon. P is the partial pressure, and the two partial pressures given here are 10 and 100 mmHg. And A and B are constants. Now, it is given that at 10 mmHg, which means P here is equal to 10 mmHg. At this condition, the concentration of acetone being adsorbed per kg of activated carbon, that is C, equal to 0.1 kilogram of acetone per kilogram of activated carbon. Now, we can substitute this P and C in the main Langmuir adsorption equation, and we'll get the equation as follows. 0.1 is equal to 10 into A or 10A by 1 plus 10P. Now, rearranging this equation, we can get an equation as 0.1 plus B equal to 10A. Let's assume this equation as equation number 1. Now, similarly, we can derive a second set of equation at 100 mmHg. So here P is equal to 100 mmHg, and at this condition C is equal to 0.4 kilogram of acetone per kilogram of activated carbon. Now, substituting these values of P and C in the main equation, we will get 0.4 is equal to 100A by 1 plus 100B. Rearranging this equation, we will get 0.4 plus 40B is equal to 100A. This is our equation 2. Now, we have to solve equation 1 and equation 2 simultaneously. So, solve equations 1 and equation 2 simultaneously. So, equation 1 we have 0.1 plus B is equal to 10A, and equation 2 we have 0.4 plus 40B is equal to 100A. Now we can solve this by multiplying equation 1 with by 10, and simultaneously we can solve this set of equations as follows. So solving this set, we'll get B is equal to 0.02, and by back substituting the value of B into the system, we'll get A is equal to 0.012. Now at 50 mm Hg, we need to find C at 50 mm Hg. And now we have the values of the constants A and B. So substituting the values of A, B and P, we can find the value of C at 50 mm Hg, which is equal to 0.3 kilogram of acetone per kilogram of activated carbon. So the correct option here is option C, 0.3 kilogram of acetone per kilogram of activated carbon.